Alright, so I'm going to do a very quick video on correlation and scatter plots. And scatter plots are, well, it's kind of exactly what it sounds like. You're going to take a bunch of data, you're going to graph it, it's going to make a, well, you'll see. Anyway, so here's the deal. Let's say that I have the temperature in degrees Fahrenheit, and you can see from my table it's 62 degrees, and then I take a look at my Y values, which are the number of ice creams sold. So when it was 62 degrees, I sold 8 ice creams. When it was 65, I sold 11. 77, sold 17. So what I'm going to do is I'm going to graph all of these. And so I've already done all the work. And when you take a look, you can see here's my 62 and 8. Here's my 65 and 11. 78 and 15. And oddly enough, when it was a little bit cooler, I sold 2 more ice creams, and that's fine. When it was 82 degrees, I sold 20, etc., etc. 85 degrees, I sold 21. 88 degrees, I sold 24. 90, I sold 27, and when it was 95, I sold 30. So the very first thing I did was I graphed all of these relationships onto an axis. Now, in order to have a positive correlation, a strong correlation, I want to see, is there a line of best fit? Is there a straight line that can go through all these points? Now, obviously, it's not going to go through all the points. That's obvious. But I want to see what happens when I take a stab at trying to draw a line that would go through many of these points. So I'm going to take my ruler. What I'm going to do is I'm going to estimate. I'm going to say, well, let's see what would look about right. And I would say maybe this looks. Well, maybe that looks about. Let's see. That might be pretty good. So let's see what happens. I'm going to take a pen. Oh, this is a lovely color. I'm going to take a pen. I'm going to draw a line that goes through these points. And let's see if it allows me to. Now, I'm going to take a quick look and just see what this looks like. You can see it goes through 1, 2, 3, 4. It goes through 4 points. 1, 2, 3 of my points are above, and 2 of my points are below. Now, that's just me estimating. And because it goes through 1, 2, 3 of the points, and like I said, 3 of the points are slightly above, and these are just slightly above the line, and 2 of the points are just slightly below, I'm going to say that this is a very, very good positive correlation, which means as the temperature is getting higher, the number of ice creams sold should be increasing. So as my x-axis is increasing, my y-axis is also increasing. The data-wise. So let's go see what's actually going to happen. You know what I should have done? I should have continued my line. And let's see, maybe I can. I'm going to... all right. So I should have done that because now it looks crummy. Anyway, so it's going to go through preferably around 50. So let's see. Now I can actually graph this. When I do, take a look at that. 1, 2, 3. It's my line, and the line that's actually generated by the computer is very strong. And not that you need to know this in 8th grade, but when R equals 0.985, 9805, that's a very, very strong correlation. If your R value is close to 1, it's very, very strong positive. That's a positive correlation. And like I said, that makes sense. As the temperature increases, the number of ice creams you should expect to sell should also increase. All right, so let's say we're going to look at something else. We're going to look at a negative correlation. And once again, I'm going to tell you what this is. This is a little bit ominous. The number of days absent is going to be my x value, and grades are going to be my y value. Now, you could be very, very smart and miss a bunch of school and still do pretty well. And you can be very, very, what's the word? Well, you could always be at school and not be very clever. But let's take a quick look. What should we expect? Well, if somebody doesn't miss any school and they're in school all the time and they're paying attention, they get a 92. One person has 1 absence and they get a 93. Person has 3 absences, they're getting an 87. You can see that their grades do in fact usually go down. Somebody had 6 absences, they had 77. Somebody else had 6 absences and they had 79. And I think this is kind of important. You can't have a function that has the same input and different outputs. If I have a 6 and it's a 77, then when I have a 6, it should be a 79. And that's true for functions, but for scatter plot, it doesn't matter. So once again, I'm going to graph this data, and here's what it looks like. And if I were to draw a line of best fit, I'll take a stab at this and just see what would it look like if I were to draw a line of best fit. So I'm going to go and grab my ruler again. And let's see. This looks probably pretty... Oh, oops. It just moved. You know, that looks fine anyway. So I'm going to grab my ruler. I'll use orange this time. And let's see what happens when I do this. Oh my goodness, that didn't look nice. I'm going to try to do this one more time. Get rid of my ruler. I have 1 below, 1 above, 2 below. This one's almost above. That one's almost below. So this looks pretty good. 1, 2, 3, 4. I mean, it looks pretty good. So let's see, 40, 50, 60, 70, 80. So these are units of 10. So it looks like 90. So that looks like about 95. So let's see, this is a negative correlation. That means as the number of abscesses increase, your grades decrease. So as your x-axis is increasing, your y values are decreasing, which means it's a negative correlation. Once again, because all the dots are very, very, very close to this line of best fit, it is a strong negative correlation. All right. So let's see what happens when we actually graph it. And I'll take a look at that. 80, 90, that's about 95. It's actually very close to what I had graphed. Very, very close. And once again, if you look at the R value, negative 0.9887, that's very close to negative 1, which means it's a strong negative correlation. All right. So just to recap, if it's if all the dots are very, very close to the line of best fit and it's going up, it's a strong positive correlation. If all the dots are very, very close to the line of best fit and it's going down, it's a strong negative correlation. There is another option, and we're going to take a quick look. Here, this is the size of television in inches, and the hours spent watching TV. So if somebody has a 36-inch TV, maybe they watch TV for 3.8 hours. 38 inches, 4.7 hours. 40 inches, 0.5 hours. And you can see it's a little bit harder to... I can still graph these. That's fine. See, 40-inch TV, half an hour watched. Person with the largest TV only watches 1.3 hours, and that's 64 inches. The person who watched the most amount of TV had a 49-inch TV at 9.6 hours. Now, I'm not really sure. Let's see how many data points I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11, so I could, once again, I could try to draw a line of best fit. And if I were to do that, let's see. I guess I'd want something like, maybe like this. But once again, I'm not really sure. I mean, 1, 2, 3, 4, 5, 1, and then 1, 2, 3, 4, 5. I mean, this, it looks like I have 5 above, 5 below, so that's good. But none of these dots, except, I shouldn't say none, many of these dots are nowhere close to the line of best fit. So it's not a very good correlation. Oh, my graph is pretty good. My line of best fit was pretty good, but it doesn't really make a difference because look, my R value is very, very close to 0. That which there is no correlation, which means you can't tell how much time somebody's going to be watching TV based on the size of their television. All right. So those are the 3 big ideas. Once again, all you do, you take your table of values and you graph them. You take a look to see, can you draw a line through the line of best fit, which goes through some of the points? Great, you can. If the points are very, very close to the line and it's increasing, positive correlation. If they're very, very close to the line, decreasing, negative correlation. If they can go through, but they're not close to the line, there's no correlation. And like I said, you cannot tell the size, how much TV somebody watches based on the size of their television. And that's it. That's video 1. We're going to do one other video, and that's all. All right? Thanks.